Project Sites or Chapter 4. I'll probably break this up into two parts. So the first half will be between from 4A to 4E, and then the second half will be from 4F to 4I. Okay, let's just get into it. So you need to know how to convert between these. Make sure you have this table down. Okay, this is reference sheet quality. Okay, you should know what these all mean. Okay, these are just the conversions. You should be able to apply them. Convert these lengths to the units shown in the brackets. Okay, so I'm converting from 35 centimeters to millimeters. So just referring back to my little flow chart here, to go from centimeters to millimeters, I multiply it by 10. So now I just go 35 times 10, that equals to 350 millimeters. Now I have 120 kilometers to centimeters. Now, as you can see, I need to apply the conversion twice. Okay, so I need to go from kilometers to meters first, and then meters to centimeters. So let's just start off with the first conversion. 120 times 1000 to get to meters. So if you type this up in your calculator, you get 120 times 1000. It's just 120,000 meters. And now to go from meters to centimeters, I multiply by 100. And you can just use your calculator. If you press times, the first thing it'll show up is answer. This answer is your previous answer, okay? So it's going to use my 120,000 that I found previously. If I type that in times 100, it'll give me 12 million instead. So this results to 12 million centimeters. Perimeter, it's the distance around the shape, okay? Now you must make sure that all side lengths are of the same unit of measurement. So, for example, if one side is centimeters and another side is meters, you need to convert one of them, okay? So convert meters to centimeters or centimeters to meters, up to you. But I think just go based off the question, okay? And whichever one's easier to deal with. Now, you must remember the marking stuff. If you see a shape with marking or dashes, it means that they are of the same length as well. So let's just go through this example here. Find the perimeter of this shape. So I have a 4 centimeters here with this double line dashing. That means this is also 4 centimeters, quite convincingly. Now, perimeter is just the distance around the whole thing. So you have 10 plus 4 plus 4, but you don't know what these side lengths are. These are all question marked for now. Well, I can tell you now for this this left question mark here, it's quite easy to tell because we have 4 centimeters from the bottom and 4 centimeters from the top. If you were to add those two lengths together, it ends up being centimeters. Okay. And as you can see here, the question mark on the top and the question mark on the far right, if you were to add those two question marks together, it's actually the same thing as 10 centimeters. So you know that the smaller line plus the larger line equals 10 centimeters. Okay. So if I really wanted to rewrite it, I could use a ruler. Let's go from this line all the way to here. And if I just draw arrows, oops, like that, this will be the same thing as 10 centimeters. So I will have 10 plus 4 plus 4 plus 10 plus 8. And if you type this all up in your calculator, 10 plus 4 plus 4 plus 10 plus 8, you end up with 36 centimeters. So it's pretty obvious, pretty easy to do. Okay. Now, this is an example of when you are given a shape. So, given shape, given perimeter, they ask you to find the missing side length, just like that. Okay. So, just have a look. I have these dashes here or these markings here, and that's X centimeters. And over here, I've got the dashes as well. So that means this must also mean X centimeters as well. Now, if you were to write out the perimeter, the formula for perimeter would be X plus 5. Okay? Because you're adding up all the side lengths. Now, this would be P is equal to 2X plus 5. Now, we are given the perimeter already. The perimeter is 19 centimeters. So we know it's going to be 19. And as you can see here, we've already accounted for 5 centimeters already. So what we can do is we can deduct this by 5. That will give me 14 centimeters. This means that between the two x's here, that equals to 14 centimeters. So it's quite easy that you can to tell that you can just split up. You can just do 14 divided by 2, and that is 7 centimeters. That means x is equal to 7 centimeters. Okay. Now, circumference of a circle. The word circumference is just a fancy word for perimeter. Okay. But the word circumference only applies for circles. Okay. Only for circles. Now, just remember the symbol pi here. So, pi is basically given whenever you take its circumference and you divide it by its diameter. Okay. And it always usually ends up as 3.1415, and then obviously the rest is history. Now, when you're doing calculations, yeah, like don't use 3.14 in calculations or 3.1415, okay? Use the pi symbol. It is more accurate. You won't need to worry about these two formulas in on the bottom as much. Okay. The one you just need to know is just this one here. Okay. Now, features of a circle. Okay. You should be able to describe um some features on a circle. Let's say you're given a diagram and like it's your job to identify, okay, which one's the diameter, which one's the radius, which one's the circumference. Okay. Use this diagram to help you. Okay. Now, the diameter is the distance across the center of a circle. So it's the black line right here. Okay. It's black. Okay. Black line. Now the radius is the distance from the center. So it says here from. The key word here is from. Okay. So that's the red. Okay. Now the radius is always half the diameter. So let's say you're given the diameter and you need to find the radius instead. Just divide the diameter by 2. It's pretty straightforward. What's this? Okay, sweet. I already have this written down. All right. So C, aka circumference, is the distance around the circle. You should know that already from the previous slides. Now, you need to know these two formulas. Very important. Okay, need to know. You need to know them. Okay. I'll just write it in blue. Reference sheet. So, depending on your question and whatever it is you're given, and they ask you to find the circumference, you need to apply one of these two formulas, depending on what you're given. Okay. Now, these two at the bottom, where it says r is equal to c over 2 pi and d is equal to c over pi, all it means is that if you are given the circumference and they ask you to find the value of radius or diameter, these are one of these two formulas that you will use as well. Okay. Not as important, but good to know and have it in your reference sheet as well. Okay. Just have it in reference sheet. Um, all right, let's just go through this really quickly. Find the circumference of these circles, correct to two decimal places. So over here in my first circle, I have 3.5 meters. This is the radius. And you can tell it's a radius because it goes from the middle to the end. That's it. Now, the formula that I will use is C is equal to 2 pi r. So C equals 2 pi r, which is the same thing as 2 times pi times radius. Okay. So if you type this in exactly into your calculator, you'll get 7 pi. And if you press this button here on your calculator, especially for those with the green one, you will get 21.99. But because we're rounding to two decimal places, it just becomes 22. Okay. Over here, we're given d is equal to 4 centimeters. So the formula we will now use is c is equal to pi d, which is the same thing as pi times d. So if we substitute the our value of diameter in, it just becomes pi times 4, which equals to 4 pi. And just press the funny symbol again. 12.57. All right, so we're working on area now. So these are the main ones you need to know. Okay, this is the flow chart. All of this is very important. So all of this is reference sheet. Okay, everything. All right. I hope that you have this worksheet here. Um, I've already made one here. You can just copy and paste it, or you can make your own one. I don't care. So we'll just briefly run through this. So some keywords you need to know is that L is length, W is width, H is height, B is base. Okay. So area of a square is L squared, which is just L times L. Okay. So you're just taking this side length and you multiply it with this side length there, or any other side length. I don't care what it is. Okay. Doesn't matter. Rectangle is length times width. Okay. Parallelogram is base times height. Okay. So the dotted line that you'll see is always the height, and this height is always 90 degrees to the base. That's what you should know. Now the triangle here, it is base times height divided by 2. So just whatever your base is, whatever your height is, multiply those two numbers first, and then you divide it by 2. Okay. Now you have rhombus and kites. They have the same formula. Okay. They have the same formula. Now, it's your job to distinguish which one's which, but it's pretty easy to tell if you just look at the two diagrams. The rhombus has like exactly the same side lengths, but it's just been tilted, okay? And then you got the horizontal distance and the vertical distance. The value of x is just the distance from the dotted line, and that's all you need to look at, okay? Area of a trapezium. So it's basically the sum of the parallel sides multiplied by its perpendicular height divided it by 2. So this is the main one that you should use just to make your life a bit easier. Let's just go through some examples here. Finding area of basic shapes. We can tell that this is a rectangle, so let's just use our formula for area of a rectangle, length times width. I have 2 centimeters, I have 6 centimeters. Substitute the two numbers in, I get 12 centimeters squared. All right, so in this shape here, this actually looks like a trapezium. So the formula for trapezium is, is it? No, parallelogram. Parallelogram, okay? Parallelogram, which is base times height. So the base is going to be 8, the height is 3. Just substitute the numbers in, 24 meters squared. Now, when dealing with area, you must always put in the squared value at the end, okay? Over here, this is a triangle, so this is just base times height divided by 2. So if I substituted the numbers in, I get 13 times 7 over 2. This ends up being 91 over 2 meters squared. And if you wanted to take it a step further, it would be 45.5 meters squared. Now, this is the area of a rhombus. So a rhombus has these 4 dash markings, okay? So you know it's a rhombus. It's basically x times y divided by 2. Okay, so doesn't matter which one's x, doesn't matter which one's y. Just substitute the values in. 8 times 5 divided by 2. This ends up being 40 over 2. And 40 over 2 ends up being 20 meters squared, just like that. Now, this is a kite. Remember, use the same formula. The rhombus for formula and kite are exactly the same. So just do 12 times 5 over 2 equals 60 over 2. And that equals to 30 centimeters squared. Now, remember, you are allowed your calculator in this test, okay? Now over here, I actually did not cover oh, I did cover the formula already. So this is a trapezium, okay? So the trapezium has 2 parallel sides, okay? So as you can see, indicated from this arrow and this arrow at the bottom here. So you just use the formula for the trapezium. So the formula for a trapezium is a plus b times h divided by 2. This is going to be a, this is going to be b, this is going to be h, okay? So let's just substitute the values in. 10 plus 6 times 5 divided by 2 at the end. I end up with 16 times 5 in the numerator. That equals to 80 over 2. And 80 over 2 just equals to 40 millimeters squared. Now, you also need to know how to work with composite shapes. So these are shapes made by putting 2 or more simple shapes together. Okay. So as you can see, they're stacked on each other. Over here, shape 1, we have a rectangle. And over here, shape 2, we have a triangle here. So they just slapped it on top of each other. Now, sometimes you don't really add shapes. You don't add shapes on top of each other. Sometimes you can have one big shape and it's been deducted by another regular shape. So you just got to be careful and pick and choose. Okay. Just look at the diagram very carefully. Now, as it's saying here, find the area of this composite shape. Now, we want to find the area of purple shaded here. That's what the goal is. Okay. Now, I can tell just using this dotted line here above that it forms a rectangle. So why don't we just find the area of a rectangle, which is length times width. It's just 10 times 6, which equals to 60 meters squared. And then the one that's not shaded is the area that we are trying to deduct away from the rectangle. Now, what shape is it? It's actually a triangle. This is a triangle right here. So I'll just do area triangle equals to base times height divided by 2. And you are given all of these side lengths already. So we're given the height, which is times 4. Now, the base, you might be wondering, you don't really recognize as much, but if you remember the rectangle that we used here, this whole distance is 10 meters, okay? So the base of this triangle will be 10 meters as well. So just substitute it into the formula, you get you end up with 20 meters squared. Now the final area is 60 minus 20, which ends up being 40. Okay. Let's just do this one really quickly. Two ways you can do it. You can make it a big rectangle and then find out the whole area of this big rectangle, deduct it with the smaller one, or you can cut it into two basic shapes and then find the area of both of these little rectangles here and then add it on top of each other. I personally believe make your life easy, just do the adding option instead if you can. Otherwise, you can get confused with what to subtracting from what as well. Okay. So I'm going to name this shape 1, shape 2. So for shape 1, it's A is equal to L times. Let's have a look here. So over here we have this double lined marking that's 3 millimeters. I have this one that's 3 millimeters as well. That means shape 1 is actually a square. So if it's a square, you just use the formula L times L, 3 times 3, that equals to 9 millimeters squared. Now for shape 2, this is a rectangle here because you have 1.2 millimeters and then you have 1 millimeters here. This 1 millimeter is just talking about that distance. I'll just redraw it. It's the distance in the purple line that I've just drawn. Okay, so this would just be 1.2 times 1, which equals to 1.2 millimeters squared. And the next thing to do is just add A1 plus A2, which equals to 9 plus 1.2, which equals to 10.2 millimeters squared. All right, so this is the area of a circle now. So you need to remember this formula. This is all reference sheet worthy, okay? Now, if you don't know how to get squared here, okay, if you don't know how to get the little 2, which is what I've circled, have a look here on calculator. Press this x squared button shown in picture. So look at the picture on the right on the calculator. It's the one that's been highlighted in red and circled right now. Okay. So when you press this button, you want to put your radius in first. Okay. Um, I'll say put radius value first. Okay. So put your radius value first. So if my radius is equal to 5, you would type the number 5 first, and then you would go here. Okay. That's just all it is. Now, this is for when you need to find a radius given the area. Okay. So this formula here, r is equal to square root a over pi. I don't think you'll need this as much, but it is nice to know. Now, as you can see, this funny Nike tick right here, this little check, this little tick, and it's got a line that goes across. This is called the square root button. Now, to get the square root button, You got to press second and then that same button that you would use for squaring, okay? And this will end up with the square root. Now you have semicircles, okay? So a semicircle is just a half circle. Looking at this diagram here, it's pretty easy to find. You can just use this formula that I've written down. Or what you can do is find the area of the full circle first and then divide that by 2. It makes sense. Now you have a quadrant, aka quarter circle. Same thing. You can do this, or you can find the area of the full circle first and then divide it by 4. Let's just go through some of these. So find the area of a circle with calculator, correct to 2 decimal places. Pretty obvious. If 2 centimeters, that equals to r. That's the radius right there. So the formula for a full circle is pi r squared. So I'm going to do pi 2 squared just like that. And that equals to 4 pi. Now let's just go based off the calculator. Oh, we've already done it. It's 12.57, okay? 12.57 centimeters squared. Now, this example here, it's you're given a circle and you know the area is 40 millimeters or 40 meters squared. Okay, that's A. And you don't know the radius, find the radius. So just use the formula r is equal to square root A over pi. And if you substitute 40 over pi in there and you type this in your calculator, square root of 40 over pi, I end up with 3.57. Okay, 3.57 meters. That means the radius is 3.57 meters, and the area of that circle, if you plugged in the radius as 3.57, ends up being 40 meters squared. It's pretty straightforward. All right, finding areas of semicircles and quadrants, pretty straightforward here. So let's just write down our formula first. So pi r squared divided by 4. We know the radius is 3. So if I substituted my value in, I end up with 9 pi over 4. Now once I type this in my calculator, I end up with 7.07 meters. Oh, yep, that's right. Now, this is a semicircle here, but as you can see, we're given 5 kilometers, but it doesn't indicate whether it's the radius or not. So what we're going to do is we're going to assume this 5 kilometers is actually the diameter instead. Now, a formula we only want to work with, we only want to work with radius, okay? So we need to grab the radius from this diameter. So radius is equal to 5 divided by 2, which equals to 2.5 kilometers. And now we can get started. So our formula is A is equal to pi r squared over 2. So pi bracket 2.5 squared over 2. And if we type this into our calculator exactly how it is, I end up with 9.82. 9.82 kilometers squared. That means this half circle, the space encompassed in here, is 9.82 kilometers squared. Okay. So this is part 1 of the video done. I'll make a part 2 and I'll upload that as soon as I can.